Hi everyone, in this lesson we are going to continue with synthesis questions, and I'm going to talk about some useful intermediates. Alright, so I hope this is able to help you with how you answer your synthesis questions. So there are a couple of useful intermediates. We have the alkenes, we have alkyl halides, alcohols and acyl chlorides. Alright, for alkenes, they allow you to change your functional groups. So example, if I have an alcohol, okay, I can turn it back to an alkene, and then I can do many things with it. All right, it will allow me to change my functional group. All right, it also allows me to add functional groups. So for example, if I have an alkene, I can turn it into an RX, I can turn it into an alcohol, and so on. All right, I can even add two functional groups to it if I convert it to a dichloro uh, alkane. Alright, so that is how I can add functional groups. You can also add functional groups with different reactivities. So for example, if I use an alkene and I form a bromohydrin, alright, these two groups here will undergo different reactions. Next up, for alkenes, we can also cleave it. Alright, so if we use hot acidified KMnO4, we'll cut this thing up and we will get two of these molecules. Right, so to cut CC carbon-carbon bonds, you can convert them to alkenes first. And of course, I can also switch the position of functional groups. So for example, if my chlorine atom is here, I can turn it into this intermediate, and finally, if I add HCl again, I will be able to get this thing. Okay, so this first step is elimination. Then the second step is my electrophilic addition. So this is a way for you to transfer your functional groups. So other than alkenes, we also talked about the halides, alkyl halides. So alkyl halides allow you to do step-up reactions. It allows you to convert to alcohols, allows you to convert to alkenes. So it's a very good intermediate. And for alcohols, why do we want to use them? Because they can be converted to alkenes. They can also be converted to alkyl halides. And one very special thing about them is that they can undergo oxidation. Lastly, if we talk about acyl chlorides, it helps you to convert to other acid derivatives, right? So that makes it very useful. So for example, if I have an amide, right, the only way for me to get an amide is to get it from an acyl chloride plus ammonia. I cannot get it from reacting a carboxylic acid with ammonia because I have a base here and I have an acid here, and then I will get acid-base reaction. So this reaction does not occur. Instead, I can do the reverse reaction of hydrolysis to get this, and then I can react with reagents such as PCl5, SOCl2 to get my acyl chloride. Right, so I just want you to take note that acyl chlorides is a useful tool for the conversion of different acid derivatives. And so I hope that this lesson on the different intermediates can actually help you to answer some of your synthesis questions. Thank you.